So for this example, we're going to write a power series for f of x equals 1 minus x squared. It's going to be centered at 0, so we're going to write out the first four non-zero terms in the general term and then determine for which x values it actually matches. Where does it actually converge? So when you look at it, you always have a question, am I doing a Taylor, or now it could be geometric. And you're looking for something in the form a sub 1 over 1 minus r, which this fits exactly. So in this case, I would say a sub 1, my first term, is 1. A sub 1 is 1. 1 minus my r, so my r is x squared. So if I wanted to write it out, it's very simple. I would say that we are looking at the first term as 1, and then to get from term to term, I'm going to multiply by x squared, so plus x squared. When I multiply x squared by x squared, I get x to the fourth. Multiplied by another x squared, so plus x to the sixth, plus, put the ellipses on, equals the sum from n equals 0 to infinity. It's not alternating. I don't have anything in the denominator. They're all just x to even powers. So x to the 2n. Now I want to know when this actually converges. So this is geometric, and we know that geometric will converge when the absolute value of your r is less than 1. So in this case, r is x squared. The absolute value of x squared is less than 1. Well, x squared is always positive, so I don't really need the absolute value. I could say it could converge when x squared is less than 1. So you can think about this all different ways, but I need, if I do it graphically, I need my x values to be smaller than 1, but I'm squaring them, so I'm making them positive. So I could actually plug in both positive and negative values for this, and I need it to be less than 1. So if you think about it on a number line, here's your 0. If I'm actually plugging in values up to 1 right here, and I square them, I'm still going to get something less than 1. 1/2 times 1/2 is 1/4. But if I go past the 1 mark, then I'm actually multiplying by more than 100% and it's going to grow. So anything in this interval will work. But it's x squared, so I can actually multiply negative numbers as well. So a negative 1/2 times a negative 1/2 will give me a positive something that's less than 1. If I go past that, say negative 2, well, when I square that, I get 4, and 4 is greater than 1. So the interval of convergence is actually, for this problem, negative 1 is less than x is less than 1. So my series will match 1 over x squared from negative 1 to 1. And again, this is geometric, not the ratio test, so you do not have to check the endpoints. We know the rule, and it will converge less than 1, diverge greater than or equal to 1.